so what we're trying to understand here is why what are indices or powers to the power of zero and to negative powers. What does that mean, and why is it what it is? So if we have a look at 3 to the power 5, we know that 3 to the power 5 is 3 times 3. Look, basically, you do it 5 times. So you get 1, 2, 3, 4, 5. 3 to the power 4 is 4 times, etc. As you go down from 4, 5, 4, 3, 2, 1, and well, as you go down to 1, we're dividing it by 3 each time, right? Or if you go up, you're timesing it by 3 each time. So 3 to the power of 1, as we go from 3 to the power 1 to 3 to the power of 2, we're multiplying it by 3. And as you go down, you're dividing it by 3. And so if you divide it by 3 one more time, you end up with just 1. So in other words, 3 to the power of 0 is 1. And that works for everything. So 3 to anything to the power of 0 is 1. So we could write that as x to the power of 0. So x to the power of 0 is 1. In other words, any number to the power of 0 is equal to 1. So what about 3 to the power of minus 1? Well, 3 to the power of minus 1 is we're going to divide it by 3 again, aren't we? So so let's have a think about that. And 3 to the power of minus 2. What would be 3 to the power of minus 1 and 3 to the power of minus 2? So yeah, as you go down, you carry on dividing it by 3. So you can see here that 3 to the power of minus 1 is 1 over 3. 3 to the power of minus 2 is 1 over 3 times 3. So in actual fact, 3 to the power of minus 2 is actually 1 over 3 squared. So negative powers are essentially equal to, in fact, we could rewrite a rule here for negative powers. So we could rewrite that as any number to the power of a negative of another number is going to be equal to 1 over x to that number there to the power of a. Okay, so so you can see that as a general rule. We've got 2 general rules here now, and obviously these would apply to algebra, but it's a kind of a rule to be aware of when you're working with numbers as well. Okay, so that's positive, 0, and negative indices. So what about fractional indices? So what about if it was 3 to the power of a half, for example? What would that be? Let's see if we can work out by logic what it would be. So before we understand how to do fractional indices, we need to look at how to combine the different indices, and it'll help us to understand what a fractional indice is, rather than me just tell you it. So 3 to the power 3 squared plus times 3 squared, well, that would be like 4 threes in a row. So we're sort of adding the powers. So actually, you've got here 2ab. It would actually be x. So it's going to be x to the power of a plus b. Okay, so I'll just write that now. So the relationship between in this case, when you're multiplying when you're multiplying different indices, so like a number to the power of a number times a number, as long as these two numbers are the same, you can group them together and do x to the power of a plus b. So we could do a sort of we'll do another sort of algebra example. So x squared multiplied by x to the power of 3, well, we can think about that as x times x multiplied by x times x times x. And that would be the same as x times x 5 times. So it would be x to the power of 5. Okay, so we're adding the two numbers together there. In this case, I probably didn't choose the best example here because I've got 2 times 2 and the numbers end up being the same. That is a coincidence, I'm afraid, so I probably didn't choose the best example, but you got this right here, though. So you're going 3 squared, and then you're going to square all of that, aren't you? So it's like 3 squared multiplied by 3 squared, and so it's 2 times 2, but unfortunately in this example it's also 2 plus 2. Anyway, so yes, that's the answer. When you do that, you end up multiplying. When you do it like that, you end up adding them. Okay, so we're going to concentrate more on this one here. Let's imagine that we had. Okay. I'll think about this now. So, for example, applying that rule on the left, we can say that's the case, right? Does that make sense?
Yeah.
So, what about then if we went the other way? So, we could start off by saying that. So, now we can actually apply that rule to this new situation and investigate what would be a fractional. What would be a fractional power then, a fractional indice? Well, according to this rule that we've just discovered, this must be true because when you put indices in this way, then they multiply out to produce this one here. 2 times 3 is equal to 6. A half times 2 is equal to 1. So what we're saying is 3 to the power of half squared is just equal to 3. So if we imagine 3 to the power of half as the unknown, and so we imagine 3 to the power of half, let's say that 3 to the power of half is equal to x. So if we imagine that 3 to the power of half is equal to x and x squared is equal to 3 according to this one here, then what would be x in this example? So to turn x squared to rearrange this equation, we would square root both sides. So we'd say that if x squared is equal to 3, then x is equal to root 3. In other words, 3 to the power of a half must be equal to root 3, right? So that means that, so let's just write that down first then. Okay, so normally you won't bother writing the 2 on the square root there, but what we're going to see here is that this number underneath the fraction is going to be is actually what the root is. So if it was 3 to the power of a third, it would be the cube root of 3. Okay, so this rule could be rewritten as this. I'll write it up here. So x to the power of 1 over n is equal to the nth root of x. For example, x to the power of a half would be equal to the square root of x. X to the power of a third would be equal to the cube root of x, and so on. So that's what a fractional power is. What about a fractional power that doesn't have 1 at the top then? Let's see if we can work out what that would be. So using the rule that we did earlier on about multiplying by doing this kind of thing, we're looking at the powers. If they're a times b, we can imagine this to be like this. Okay, because when it's in the brackets, we go this times that, which is end up being to this. So we can say that's identical to that. Okay, and then we would say, well, we've discovered what it means when you have a fractional indice with 1 at the top. That would be the fourth root. Okay. So that's what you would get if you combine them. Okay, the 4 at the bottom, that goes like that, and you can end up having a fourth root there, and that is to the power of 3. So that's everything on powers. We've got. Let's just recap here now. Oh, come on then. Or indices. So we know that what indices are. The number basically means how many times you multiply it, but it gets a bit weirder when they become non-positive integers. So let's go down. 3 to the power of 0 is equal to 1. We explained why that was the case. 3 to the power of negative 1 would be 1 over 3. 3 to the power of minus 2 would be 1 over 3 squared. Anything to the power of 0 is always equal to 1. Anything to the power of minus something is equal to 1 over 1 over x to the power of a in that case. And we also looked at how when you combine powers in this way, like x to the power of a multiplied by x to the power of b is going to be equal to x to the power of a plus b. Whereas if you do x to the power of a all to the power of b, you multiply them. So in this case, you add them. In that case, you multiply them. Then we use this rule to understand what a fractional power would be. So 3 to the power of a half is actually the square root of 3. And in fact, that can be written as a rule. X to the power of 1 over n is equal to the nth root of x. We then use this rule and this rule that we just worked out to understand what it would be if you had this kind of fraction where the top number is not a 1. And we said, well, 3/4 is the same as 1/4 times 3. So 3 to the power of 3/4 would be the same as 3 to the power of a quarter, all to the power of 3. And 3 to the power of a quarter is the fourth root of 3, and then we'd put all that to the power of 3. So that's how you would do that. I might have missed out a couple of things on indices, but we'll leave. That's a pretty good overview of indices that you need to know. So we'll stop just there.